So I'd like to talk about how to add and subtract fractions when there are different signs for the fractions. Also, then we can add in variables, and we will, but let's first deal with fractions without variables, and then I'll put some variables in. So if we're subtracting one fraction from another or adding two fractions together, you always need to have like denominators. So the like denominator in this case is going to be 15. So you can just get started by putting 15 for both of them. And then whatever this sign is, usually we would put it down here. But what I'm going to say now is whenever you see a subtraction sign, I highly recommend, you don't have to do this, but as you're starting out, I highly recommend that you take subtraction signs and you turn them into plus negatives, okay? So just like 5, that might be a little bit off of the video, but just like 5 minus 3 is 2, right? The same thing is true for 5 plus negative 3. So if I turn this subtraction sign into a plus negative 3, 5 plus negative 3 is also 2. So I can change this subtraction sign into a plus negative, right? That's going to help us out a lot when we try to combine both of these fractions. So let me bring down this addition sign, and then I need to make sure that whatever I did to the denominator, I do to the numerator. So 5 times 3 is 15. 5 times negative 2 is negative 10. So negative 10 fifteenths is the same thing as negative 2/3. They're equivalent fractions. Okay, now 3 times 5 is 15. So now I'm going to multiply 3 times negative 4. So that's why I did this plus negative, because now it's obvious that I really want this negative to come down here as well. So 3 times negative 4 is going to be negative 12. So negative 12 fifteenths is equivalent to negative 4 fifths. Okay, now we just go ahead and do our addition like we would with any other kind of fraction problem. So remember, you just keep one of the denominators. We're not adding the denominators. You keep the denominator, and then you do whatever is in the numerator. So here it's negative 10 plus negative 12. And now negative 10 plus negative 12 is its own problem. So if we were to have this just as an integer problem of what's negative 10 plus negative 12, we would say, oh, well, that's going to be negative 22. And then it's all going to be over 15. And if you can reduce, you need to, but there's no common factor between 22 and 15, and so that's going to be our answer. If you want, you don't have to, but if you want to, you can divide 15 into 22 to make it a mixed number. So that's fine if you want to do that. That would go in 1, 7 left over. So that would be negative 1 and 7 fifteenths if you want to do that. Okay? No need to. Improper fractions are totally fine. And then the last thing I want to say is negative 22 over 15 is a negative fraction. And negative fractions, when you only see one negative for a fraction, that means it's a negative fraction. And so there's 3 ways to show that. You could have the negative in the numerator, you could have the negative in the denominator, or you could have the negative right out front. But all of these terms are absolute equivalents, okay? As long as there's one negative sign somewhere, it means that the whole thing is negative. So I want to contrast that to if we put a negative in the numerator and a negative in the denominator. If we have 2 negatives, meaning we're dividing negative 22 by negative 15, whenever we have a division problem where we have 2 negatives, your answer is going to be positive. So if we have 2 negatives here, that's equivalent to a positive 22 fifteenths. So these are equivalents, and these are equivalents. Okay, these are all negatives, and these are all positives down here, because these 2 cancel each other out. Okay, so now let's get into doing something with some variables. So let's say that we had negative 4x over 5, and I don't know, maybe minus, we're going to subtract 2x over 4. Okay, so again, we're going to do everything like we did in the last problem, except we have some variables, but we still need to have common denominators, so 20 is going to be the common denominator. There's a subtraction sign here, so I'm going to turn that into a plus negative. And I multiplied 5 times 4 to get 20, so I'll multiply 4 by negative 4x up here to get negative 16x. Bring down the plus, and then 5 times 4 is 20, so 5 times negative 2 is negative 10 and x. All right, so now we're going to add these two fractions. We're going to keep one of the 20s, and then it's going to be negative 16x plus negative 10x. We can go further because these two terms in the numerator are like terms, meaning that since these are both just x's, not x squared, not xy, just x by itself, they are like terms, and we can then add or do whatever else we need to as we're asked. And in this case, we're asked to add these two sums, add these two terms to get a sum. So negative 16 plus negative 10 is negative 26. So that's negative 26x on top over 20. Now this we can reduce. So we need to reduce it because they both have a factor of 2. They're both even numbers. So 2 into both of these, that would give us negative 13x over 20. And I can't reduce that anymore. Here's something I like to say. This is equivalent, so this is totally fine, and this is also equivalent to this. So you can write either of these and they mean the exact same thing. It doesn't matter which way you put it. Here's something that you cannot do. These do not equal what I'm about to write down. So these equal each other, but I'm about to write something that is not equal to this. That would be wrong if you wrote it. These are not equal to this. X cannot be in the denominator because if x is in the numerator, it can either be put in the numerator or it can be put out front in a big old that covers everything, but it cannot drift down into the denominator. Okay, so yeah, I mean, this could be a term. This is absolutely a great term. It's just absolutely not equivalent to these terms. Okay, what this term is equivalent to would be negative 13 over 20 times 1 over x, times 1 over x, not times x. Here it's being multiplied by x. These are multiplied by x. But here, this is the equivalent of multiplying by 1 over x. That's why it would be in the denominator. So, very important. That's why a lot of times when students write something a little bit carelessly, they're like, oh, 2/3 x. Like, is this x supposed to be in the denominator? Or is it supposed to go for the whole fraction? So, if you tend to write fractions a little sloppily like this, there is an easy fix, and the fix is to put a parentheses around that coefficient, okay? And now there is absolutely no doubt that what you are writing here is this. So this equals this, and because I put the parentheses around, this x is not going to be shoved into the denominator, because now the x goes for everything. So if you want to write this, but you're sometimes a little sloppy, just put a parentheses around your coefficient, and then you'll be totally fine, okay? So again, this is whatever's in front of the variable is called a coefficient, okay? And then the variable is going to be multiplied against the coefficient. Okay, so that should do it, and I'll give you a couple questions and see if you can follow along. Thanks.